Hi everybody, we're going to talk about chapter 12 now, and we're going to talk about means and medians and standard deviation. Means, which you actually know as sample average. We're going to talk about median, and we're going to talk about standard deviation. And what we do in this movie, we're going to do by hand. And then I'll also have another one to show you how to use the computer to do it. Won't that be fun? Ooh-wee. Okay, good. We're going to replace that. Okay. So, suppose I have the following data set. I have 2, 5, 8, 4, and 1. And I want to find the mean. And the mean has a special symbol. It's called X bar. So to get the mean, you just take 2 plus 5 plus 8 plus 4 plus 1. You're going to add those up and divide by 5. The reason being there are 5 data points in there. So we have 7, 15, 19, and 20. 20 divided by 5. So that's going to be 4. Good. So that's your sample mean, and you probably know it, as I mentioned, as your average. All right. Then to get the median, I'm going to change to the next slide. To get the median, so you had 2, 5, 8, 4, and 1. That's your data set. The first thing you will do is put the data in order from smallest to largest. So you're going to have 1, 2, 4, 5, and 8. All right, there's 2 ways to get the median. It depends on the number of points in the sample. So we have n, the sample size, is equal to 5, and 5 is an odd number. Okay? So when we do that, you're going to start, sometimes I call this the scratch and sniff method. You're going to take the last one and scratch it off. Or my fault. The first one, scratch it off. The last one, scratch it off. Then second one, second to last, and whatever's left over is your median. So the median, and I usually give it to notation X subscript MED is 4. Now we're going to do an example in a minute where you have an even number and you're going to have 2 values left over and you're going to actually average them. Okay, but hang on a minute. So then the next thing we have to do is calculate the standard deviation. Okay, so it has a terrible looking formula, but what we're going to do is line them up in rows, or excuse me, in columns. So here's our values. We had 2, 5, 8, 4, and 1. When you calculate the standard deviation, it really doesn't matter if they're in order or not. And I'm going to add those up. All right, when I add those up, I know from before that the total was 20. Then I'm going to square each one of those values. I'm going to call that x squared. So 2 squared is 4. 5 squared is 25. 8 squared is 64. 4 squared, is 16. And 1 squared is 1. Excuse me. Now I'm going to add those up. So I have 29, and let's see, 64 and 29 are, how about 93? And then 93 and 16 are 109. How about 110? I hope this is right. Okay? Everybody all right with that so far? Good. So let's write down our formula, and it's going to look really scary. May I flip? Good. So our formula, and I'm going to use script S. This is actually the variance, and I'll show you why we're doing this first in a minute. The variance is the summation of the x's squared minus the summation of the x's squared over n, the whole thing over n minus 1. So about now you should be saying, I didn't sign up for this. What are you talking about? Okay? Well, the variance is standard deviation squared, first of all. And where are all these horrible looking things coming from? All right, let me go back to the previous page for a moment. Okay, now we're... Sorry about that. Okay, the summation of the x's squared, it's not letting me go back and forth, is that 110. That's the total of the second column. The summation of the x's, that's the 20. Okay, so don't panic. Not even for a second. The n is the number of points in the sample, which was 5. So we can start putting this all together. So we're going to have s squared is equal to 110 minus 20 squared over 5, the whole thing over 5 minus 1. Okay? Good. All right, so let's change the page. And that's going to be 110 minus 400 over 5 all over 4, or 110 minus, let's see, 400 over 5 should be 80 over 4. Sorry, that should be a squared. And then s squared is equal to 30 over 4, and that should be 7.5. Okay, so our variance is 7.5, and we're happy with that. And to get our standard deviation, we'll take the square root of that. And I cheated. I actually have R open on another computer. When I take the square root of 7.5, I get 2.738, or about 2.74. Okay? That's what I'm really looking for, is the standard deviation. It's in the same units as my original value. Now this one was just a practice problem, so it didn't really have units, but let's just say for arguments they were dollars. So you don't have dollars squared, so the variance would be in dollars squared, but if you take the square root, you're back to dollars again, which is as it should be. Okay? All right, so that's enough for this one, and I will make up a second one that has the examples with the even number.